Hey guys, this is G here. In this video, we're going to take a look at evaluating radians on the unit circle. Now prior to this video, we evaluated angle measurements on a unit circle, but instead of evaluating in radians, we evaluated as degrees. So in this video, we're going to evaluate angle measurements as radians. All right. So before we do that, let's take a look at the unit circle. So I'm going to use the unit circle that we worked on from in the previous video. All right. So now we're going to be looking at radians, which are expressed as pi. So we start at 0 degrees. That's our starting point. So that would represent 0 radians. And then we'll go to the angles in the first quadrant, which are reference angles. So we have 30, which is pi over 6, 45, which is pi over 4, 60, which is pi over 3, and then we go to 90 degrees, which is expressed as pi over 2. All right, so we express this as half of a pi. All right, and then we go from pi over 2 to 180, which is a full pi radians. Now, earlier I had you guys look through a handout about radians, and in that handout, there was a section where I stated that a semicircle, which is 180 degrees, equals to 1 pi radian. All right, so 180 degrees equals to a full pi. All right, so then we go from 180 degrees to 270 degrees, which is expressed as 3 pi over 2. All right, so we have 3 pi over 2. So if we were to change 3 over 2 into a decimal, we get 1.5 pi. So we go from 1 pi to 1.5 pi. All right, and then we go from 3 pi over 2 to 2 pi, which is a full circle. So 2 pi equals to 360 degrees. Let's say I wanted to express the radians into decimals just for the quadrantal angle measurements. So we have from 0 to pi over 2, which we could rewrite it as 0.5 pi. And then we go from 0.5 pi to 1 pi. And then we go from 1 pi to 1.5 pi. And then 1.5 pi to 2 pi. All right? But just to make it easier, we're just going to leave it as fractions. All right? So let's take a look at the first example. Let's take a look at a few examples, starting with the first one. So in example 1, we have sine of pi over 6. So when evaluating angle measurements in radians, we do the same exact process just like in the previous video, where we have to ask ourselves 4 essential questions. The first question is, which quadrant does this radian lie on? And if we take a look at my unit circle, it's in the first quadrant, which is one of the reference angles. So we have 30 degrees, which represents pi over 6, all right? And in that pi over 6, we have our x and y coordinate, which we established right in the beginning of this unit in the unit circle video. So we have root 3 over 2, comma 1/2. And since we're evaluating with sine, for sine, we just take a look at the y coordinate, of theta. So sine of pi over 6 is going to be 1/2. So sine of pi over 6 equals to 1/2. And luckily, we don't really need to ask ourselves the rest of the question. If it's going to be a positive, what's the reference angle? Because if we recall, the reference angle in the first quadrant is the angle itself. All right, so now let's take a look at the second example. So in example 2, we have sine of 7 pi over 6. So now we're definitely taking a look at radians that are not in quadrant 1. So we have sine of 7 pi over 6. All right. So now the first thing I need to figure out is which quadrant does 7 pi over 6 lie on? Now, if we take a look, 7 pi over 6 definitely goes above pi. So it's going to be in between pi and 3 pi over 2. All right, so 7 pi over 6 is going to be in the third quadrant. All right, so in the third quadrant we have, so it's going to be in the third quadrant. All right, so we have quadrant 3. All right, so now my second question is, what is the reference angle for 7 pi over 6? All right, so since 7 pi over 6 goes passes pi, I'm going to take 7 pi over 6. So for reference angles, I have 7 pi over 6 subtracted by pi. Now, the technique to figure out the reference angle in radians is the same exact technique as if we were doing it in degrees. So if we're trying to figure out a reference angle in the third quadrant, then we take that angle measurement in the third quadrant and subtract it to either 180 or pi. They both mean the same thing. So we have 7 pi over 6 minus pi. So since we're subtracting in fractions, I need to make the denominators the same. So I'm going to change this as 7 pi over 6 minus 6 pi over 6, which is pi over 6. So that is my reference angle. Okay? So my reference angle for 7 pi over 6 is pi over 6. So sine, all right? So sine of 7 pi over 6 is similar to evaluating sine of pi over 6. But it may be equal to each other, it may not be equal to each other, depending on if the outcome is going to be a positive or a negative. And since we're dealing with sine, we're looking at the y value of that degree, or in this case, radian. So if we're taking a look in my third quadrant, both x and y coordinates are going in a negative direction, since we're going on the left side of the x-axis and downward on the y-axis. So in this case, the output is going to be a negative. So sine of 7 pi over 6 is going to equal to negative sine of pi over 6. And if we evaluated sine of pi over 6, we just look at the y value and it's going to be a half. So sine of pi over 6 is 1/2, but then we have the negative in the front. So my final answer would be sine of 7 pi over 6 equals to negative 1/2. All right? So we're going to do the same exact procedures for the next two examples, starting with example 3. Now, example 3, we have cosine of 5 pi over 3. All right? So if we take a look, we have 5 pi over 3, and by just looking at the fraction 5/3, if I were to express this as a decimal, it seems like it's definitely going to go above 1.5 pi, which is 3/2. All right? So 5 pi over 3 would be in between the third quadrant and the fourth would be in the fourth quadrant, in between these two radians. So in example 3, 5 pi over 3 would be in the fourth quadrant. All right? So then we got to figure out, well, what is the reference angle for this one? So to figure out the reference angle, I'm going to take 2 pi. I'm going to take 2 pi and subtract it to 5 pi over 3. Yet again, we're subtracting in fractions. I got to rewrite them as, they both have to have the same denominator. So I'm going to rewrite it as 6 pi over 3 minus 5 pi over 3, which equals 2 pi over 3. Now remember, I'm just rewriting 2 as 6/3. All right, so my reference angle for 5 pi over 3 is pi over 3. Now, before I move on, I don't know if you guys are noticing some sort of shortcut, some sort of pattern when finding a reference angle of a radian. Usually, so from the past two results, we have the third one, which we were looking at 5 pi over 3, and then my reference angle is pi over 3. And then in a previous problem, we were looking at 7 pi over 6, and my reference angle is pi over 6. So usually when trying to figure out a reference angle of a given radian, we just usually match the denominators from the given radian to one of the radians in quadrant 1, either pi over 6, pi over 4, or pi over 3. And if I were to match it, 5 pi over 3 and pi over 3 has the same denominator. So it is possible to avoid, maybe it's possible to take a shortcut and avoid this step. But just to be safe, if it's consistent, then we could actually avoid it. So let's take a look at over here. My reference angle is pi over 3. So cosine of 5 pi over 3 is similar to evaluating. So I'm going to write it down here. So I have, let's take a look, cosine of 5 pi over 3 is similar to evaluating cosine of pi over 3. Now the only thing we have to figure out is whether the output is going to be a positive or a negative. And since we're looking in quadrant 4 and evaluating cosine, we're looking at the x-coordinate of the angle measurement. And for cosine, since we're looking at the x-coordinate and we're on the right side of the x-axis, this is actually going to be a positive. So these two are actually equal to each other. So if I take a look at cosine of pi over 3, so cosine of pi over 3, my x-coordinate is 1/2. So cosine of 5 pi over 3 equals to 1/2. So I'm going to rewrite this over here. Cosine of 5 pi over 3 equals to 1/2. All right. So this would be my final answer, 1/2. So the process of evaluating your radians is similar to evaluating when in degrees. All right, so let's take a look at example 4. Now example 4, we're actually evaluating tangent of 3 pi over 2. And if you take a look at 3 pi over 2, let me move this over here. If you take a look at 3 pi over 2, it's actually one of our quadrantal angle measurements, specifically 270 degrees. So in reality, I'm evaluating tan of 270 degrees. So for tangent, what you do is you take the y-coordinate and divide it by the x-coordinate. So for my x and y-coordinate for 270 degrees is going in a downward direction. So from my x and y-coordinate for 270 is going to be 0, -1. All right, if you guys recall, the measurement, from the center, usually at the origin, to the end point of the circle is a radius of the unit circle, which has a measurement of 1 unit. So depending on what direction is going in, I'm either going to have a +1 or a -1. All right, so we have 0, -1, and then what I'm going to do for tangent of 3 pi over 2, I take -1 and divide it by 0. And if you recall, if you ever divide a number by 0, let's do it in a calculator. So -1 divided by 0, you get an error because you can't divide a number by 0. So usually what we would write it as would be undefined. All right. So my final answer for tangent of 3 pi over 2 is undefined. Okay? So we took a look at 4 examples where we evaluated radians on a unit circle. So now we're going to take a look at just 2 examples where we're looking at coterminal angles. All right? So we're looking at radians that are either below the range or above the range of 0 radians to 2 pi radians. So to figure out, so what we need to do is the same exact thing that we did in the previous video when we had to figure out the coterminal angles in degrees. We're going to do the same thing for radians. All right? So what we need to do is we either need to add or subtract the given radian to 2 pi to get a radian in between 0 to 2 pi. starting with starting with example 5. So we have cosine of negative pi over 3. All right. So this radian is definitely below the range. So we need to get it back up where the radian is in between the range. So I'm either going to add or subtract this by 2 pi. If you guys said add, then you're absolutely right. So what I'm going to do is I'm going to take, all right, so what I'm going to do to figure out the coterminal angle, I'm going to put my work to the, here, let me see. I'm actually going to do it over here. So I have negative pi over 3. So I'm going to add it to 2 pi. And remember, since we are adding 2 different denominators, and then you make the denominators the same. So we have negative pi over 3 plus 6 pi over 3. And when I add these two, I get a 5 pi over 3. So this is my coterminal. So I have my radian, I have my angle that is coterminal to negative pi over 3. So cosine of negative pi over 3 is the same thing as evaluating cosine of 5 pi over 3. So now what we need to do is we need to evaluate cosine of 5 pi over 3. All right, so now what we need to do is we need to figure out which quadrant 5 pi over 3 lies on, and what is the reference angle. All right, so if we take a look, 5 pi over 3, if we take a look, 5 pi over 3 is definitely passes 3 pi over 2, so it's going to be in the 4th quadrant. So we know that it's in the 4th. We know that 5 pi over 3 is in the 4th quadrant. And if I were to figure out my reference angle, so I'm going to figure out the reference angle over here. I take 2 pi and subtract it to 5 pi over 3. All right, and then what I need to do is I need to make the denominator the same. So I'm going to do 6 pi over 3 minus 5 pi over 3. And when I subtract those two, I get pi over 3. So we do end up with the same denominator as the angle, the radian that's coterminal, even the original one. So you actually don't really need to do the work to calculate the reference angles to follow the shortcut. All you need to do really to figure out the reference angle is match the denominator that you're given in the radian to one of the denominators for the reference angle. In this case, is pi over 3. So cosine of 5 pi over 3 is the exact same thing as evaluating cosine of pi over 3. All right? And since we're looking at the fourth quadrant and we're evaluating the x-coordinate, and it's on the right side, then my output is going to be a positive. So these two are going to be exactly the same thing. So cosine of pi over 3 equals to cosine of 5 pi over 3, which also equals to cosine of negative pi over 3. So I'm going to draw an arrow to put my final answer over here. So if I do cosine of pi over 3, I'm looking at the x-coordinate, which is 1/2. And since all of them are going to be a positive outcome, cosine of negative pi over 3 equals to 1/2. All right? So this is going to be my final answer. All right? So, so we have this as my final answer, and then we're going to do the same thing with example 6. Now with example 6, we're looking at 8 pi over 3. All right? So with 8 pi over 3, it looks like we have a radian that's way above 2 pi. Because if I were to express 8 thirds as a decimal, we're going to get 2.11. 2.111 or 2.33, something like that. But it's above 2. So what I'm going to do is I need to bring this down. I need to bring this radian down to the range of 0 to 2 pi. So what I need to do, I need to subtract to figure out the coterminal angle. So what I'm going to do this time is actually label first. So we have coterminal. So I have 8 pi over 3 minus 2 pi. I need to make the denominators the same. So I'm going to change it into 8 pi over 3. Well, this stays the same, but 2 pi can be rewritten as 6 pi over 3. So I'm just changing 2 to 6/3. And once I get that, and I subtract these two, I get 2 pi over 3. So 2 pi over 3 and 8 pi over 3 are coterminal angles. So we have 8 pi over 3 and which is equivalent to evaluating sine of 2 pi over 3. So we have these two. So now what I need to do is I need to evaluate sine of 2 pi over 3. So that's the first step. So now my second step is evaluating sine of 2 pi over 3. But now I need to figure out which quadrant 2 pi over 3 lies on, and what is the reference angle. Those are the two things I really need to focus on. So if we take a look, 2 pi over 3, it definitely passes pi over 2, and definitely passes pi over 2. So it's in the second quadrant, in between pi over 2 to pi. All right, so we're looking at quadrant 2. And then I got to figure out my reference angle. Now, since we've been actually doing the work to calculate the reference angle, and we've been getting the same denominator for the radian that we're given to one of the denominators in quadrant 1, we're actually going to skip the work and just match them. So we have 2 pi over 3, and the denominator and the radian that has the same denominator is 60, which is pi over 3. So my reference angle for this one is just going to be pi over 3. Okay? So now sine of 2 pi over 3 is, we take a look, is going to be similar to evaluating sine of pi over 3. Now with this one, since we're looking in the second quadrant, we see that since we're evaluating sine, we just look at the y-coordinate of the angle measurement. And since we're looking in quadrant 2, the y is going up, which is a positive direction. So if I were to look at sine of pi over 3 for my y-coordinate, it's going to be root 3 over 2. And since in quadrant 2, we're looking at the upward direction on the y-axis, this outcome is going to be a positive. So these two are exactly the same, which is also same as 8 pi over 3. So my final answer, I'm going to draw it in another arrow. So sine of 8 pi over 3 is equals to root 3 over 2. All right. So we definitely were able to evaluate angle measurements in radians on the unit circle, and the process is actually similar to evaluating in degrees. It's just a little few differences, but the process for evaluating either in degrees or radians are not completely different from each other. All right, if you guys still have any other questions, feel free to email me. Hope you guys have a wonderful day.